go back to the workbench and then drag ACPPost onto the static structure. This will translate the solution, and click edit, and this will bring up ACP module again. This is a little different than the pre-processing module, although the information from pre-processing is still there, but you can't change it now from here. For post-processing, we can see the solution is right here, and then the definition, we can detect, rotation angle, thickness, shear, and all these different things. The one thing we want to add in definition is failure criteria. This is to help us determine if apply fails or not. A good failure criteria to use is Saiwu failure criteria. That's one of my favorites. And then we also want to detect if there are any core failures for sandwich structures. So check those boxes and click OK. Alright, to view the solution in ACP, all you need to do is to create different scenes. So to do that, for the first one, let's figure out the in-plane stress at each layer of the composite. So to do that, we just right-click on the scene and create a scene. This will bring up the dialog box. Let's say this one is the in-plane stress. Just give it a name. And then we want to bring in the solution. So which solution we want to use? We want to use the one that's from the static structure, so solution 1. And you can turn on the deformation or not. It's your choice. And then in contour plot, this is really important here. So in contour plot, you want to change the definition. We're looking for in-plane stress, so change it to in-plane stress. Ply-wise means that we're going to analyze each ply at a time. So keep that box checked, so we want to do that. And then the spot. So what happened is the strain experience as you move out from the middle plane for composite material, the strain is going to be different. So therefore the stress is going to be different at each location. This means that each ply is going to have two different stresses. One on the top, so the top and bottom surface will have different stresses. So this allows us to select which one we want to view. For this case, we want to view the top, but just to show you, you can also view the bottom. I think the middle just takes the average of the two. So let's do the top, and then for the component, so basically which principal direction we want to look at. We want to look at the fiber direction for right now, so keep that the same. If you want to look at, shear or transverse direction, you have all the options in here as well. So let's look at the fiber direction and click OK. So this creates a new scene. It's different from the first one. And to view the result, you want to expand the model ply group. Let's say we want to see what the stress looks like in the front. You expand the plies. And you expand the stacks, and then click on each ply individually, and this shows what the in-plane stress is, or the fiber stress looks like, the contour plot looks like, and it looks like the maximum stress occurs at the suspension point where the suspension is attached, which makes sense. So the second layer is going to be different, and then the third layer and fourth layer. So basically each layer you can see what kind of stress that layer is experiencing. This is really neat. And then if you go to the different parts for the back, and you expand the stack, you can view each layer that way as well. And then another one we want to look at is that's important. We want to detect any core failures. One way to do that is to create another scene. So create another scene, and then we'll name this core failure. And once again, bring in the solution. I always check the deformation. And then in the contour plot, we want to select failure criteria. So detect where it fails. We can do it ply-wise, and let's try it without without the plywise. So it's going to analyzing everything together. To detect any core failures, you want to check failure mode, plot deformation, show critical failure modes, and also critical layers. So let's check those boxes and click OK. So what this does, hit update, is in this scene it shows if there are any failures. Now we used Sai-Wu criteria. So basically the constant number we use is 1, so anything over 1 is considered failure. So if you see any red on the monocoque, that means that area has experienced some failure. And another thing is the code showing on the monocoque. This number also shows you what type of a failure it's going to be. It's showing the failure mode. So basically it's the critical case. And if you want to look at the failure layer by layer, if you think this is too messy, you can, all you need to do is just create another scene and name it failure analysis, and then bring in the solution, deformation, and go to control plots, select the failure criteria again, and then do plywise. If you select OK, this will analyze the failure mode of each ply. So if you click on, for example, the plies in the front, it shows you their conditions against failure criteria. Basically, we're not putting a lot of load with number of ply we're putting on the monocoque, and it's not going to fail. None of the layers are going to fail in this case.